Welcome to Wickerson Studios. This is a introductory course into the Ghpython node for Grasshopper. The main difference you're going to find within this tutorial video series is I'm switching as much as possible the Rhino Script syntax over to Rhino geometry. And this is for people that are interested not just in Rhino geometry, but specifically the Rhino namespaces and trying to work closer and getting closer to shifting over to maybe visual scripting, node scripting into Python so you can make the jump into C# as a developer, Rhino developer. And you may want to go there immediately because there really isn't a lot online that's not very dependent on the Rhino script syntax functions, which are already written for you. So I'm breaking those down and trying to find out from absolute basics, starting with points and vectors, what has to happen in Rhino, importing Rhino to make a script run. So the first script we're going to look at is basically we're looking at points in this series, and all these points are being generated through a very interesting system, and you can go there and see where we end up. The first thing we're going to look at, I'm going to turn off everything except for the point we're actually focused on, is you're going to want to know how to go into Maths and grab yourself a Python node and drag it into your page. You're going to want to know how to go in and right-click and, well, first off, you're going to want to go in and learn how to right-click and open a Rhino script editor. And that's exactly what I have up here from the older one. You're also going to want to go in and know how to change the names of things. And you're going to want to know how to right-click and go in and change the type hints to what you need, be it an integer or a float or a value, that's or an object, geometry. And you also want to set things to item access, list access, or tree access. That's just to start. Probably won't do any graphing or flattening in here, but we may. We're not going to use that as an example. We're going to use the scripts I wrote as an example. So this script running is based on the Rhino script syntax. At this point will move in the XYZ to this point parametrically. But I have imported Rhino geometry as RG, and I want to move away from that a little bit and go back to the basics of importing Rhino, basically. And then whenever you have to type in, I would type in Rhino.geometry, and you'd follow the tabs, and you're actually using this dot system, which allows you to get to where you need to go. And there's really literally a nice walk through that. So if I had point 2 equals, you type in Rhino, hit your dot, and you're going to need the cap on it. And then you can see here, if I type G, it goes down to geometry. If I hit here and hit point, it's going to go down to point 3D. And then when I hit my space, it tells me exactly over here what I'm going to need. And it tells me wonderfully you're going to need a float. X is going to need a float, Y is going to need a float, and Z is going to need a float. So I've set these all the floats. So that should absolutely work perfectly, and you're using the dot system, and you're learning how to script in Rhino Common. That's a pretty simple first example. Close it by hitting OK. You can test, but it'll keep it open. Roll down to your next script, an array of points, and we'll go in here and see that there is an array of points, which is fairly interesting in a couple directions, how it's been made. You also want to take a look at the script, open it, import Rhino. I've left the one we just used, but I will be using points and creating an empty list with square parentheses. And then I'm going to use a for loop as I iterates through X, which is start, 0, all the way up to the end. Let's start it at 1. It stops at 10, so we can take that up to 10, or leave it at 8 maybe. And we want our steps to be the steps in between. You can see what happens if you count by 2, 3, or 1. And that is basically, you put your colon in, you have to follow your indents. If you're not following this format, you're going to have a very hard time with Python. And the point is definitely rhino.geometry.point3d. You follow that till the parentheses. And then I've just played with a little math without importing math and taken the iteration number 0, starting at 0, and going from I to I times I for Y and I times 2 for Z. And it gives me a pretty interesting little curve that if I interpolated later, you'd see what it does. You have to take your points and append it with those points within the function. Then you leave it and you output A to what you want to have as an output, which are those points. I hope that makes sense. Fairly simple introduction. Conditional array of points, fairly interesting. Let's go in and see what's happening here. We'll look at it along this side. You can see here, I have a start, step, stop, the exact same thing. And if we go down to it, I've made a list of points for the I in the iteration x. So x is a change of how long I want that to go. If I is less than y, so if I set y up in the y, make y the stop. If the iteration is less than y, then it will do something, and if it's else, it will be higher than the count of 3 or 4 or 5 that I have it set to, and then it will jump up in the z, whatever height I want the z to go. So that's actually moving up and down. So that should give you an idea of what's happening there. It's a little conditional that uses the elif statement, teaches you a bit about Python, gets your script running, and you're kind of following what you're doing. Maybe just to simplify this, I'll take out that sample. We don't need it anymore. Import Rhino, points, very simple little script, and a conditional organizable string at that. All right, let's go down here, and for some reason I got so excited about this array of points I did it twice. So I'm just going to close out my last function, script, open this one, and I had some fun with this one. You might say, how did that surface, how did that get generated? And initially it was not that. It was actually very simple. I just had this set at 0, and I ran it as a test. You'll see it just became a flat grid of points. But I wanted to make an empty list, and for I in range n, and I made that parametric, and I had to go in and set it the integer. I can change the n value to be different from the m value for the j loop. So it's a nested loop of j and I. And then I thought it would be interesting to play with a little bit of the maths, which I do all the time. We're just going to lift this x by the I iteration, y by the j iteration, and I times j just becomes a pretty interesting geometry. So to start wrap your head around things like that. And of course, I put out another cap on my j for some reason, which doesn't run because capital J is not small j. There you go. You've got a nice little wedge system that comes up pretty beautifully as a form. And you can start to put surfaces on that. But really nice, simple tools in Python to get an array of points and start playing with things. And even though it was a 2D array, it's now become a 3D array because of me. All right, we'll close that out and we'll go on to the next one. The next one are conditionals, and they're a pretty interesting monster here. So what they are, if I can scoot in here, is I'll show you, they look like this, and even though you're seeing all the other geometries, just focus on the grid at the bottom. And I've got a way of organizing and pulling these points out, and they're all based on a conditional. They had a nice pattern to start, but I played with it so much, if I put it back to a step 1, you'll see a really nice pattern that happens. But when I start to play with my start, step, stop differently, you get a whole different set of points that do different things. And that's just kind of fun to play with. So I'm just playing with patterns, setting it down at 2, and you can see the difference. But let's take a look at the script. You have to make 3 blank lists, one of which is points 1, points 2, and point 3 are empty lists made with square brackets. I'll take out that initial point. I want you to keep in mind that we're not using the Rhino Script syntax. We're using the Rhino.geometry namespace, which means we have to use point3d instead of add point. So that's really the only change that's happened in these scripts. Making them parametric and changing them up a little bit is moving away from the template of the book, and you can see how that has a interesting effect and where you can go with these things. So I have a nested loop of I going from start 0 to 100, and we could change this and make it more reasonable in scale very simply by 5, 50 by 50. And that's going to shrink it down a little bit, and we'll be dealing with a much smaller area to find a pattern in, so it's not so optically crazy. Ignore all this other stuff. It's from other scripts we'll get to in a minute. And then point is going to be equal Rhino.geometry.point3d will come up, hit the parentheses, and then I type in my x, y, z's, which will be my iterations I, j, and 0, because I want it to be. But once again, we could do a very interesting pattern of what we did in the last one. Wouldn't take much to change it. I times j, and you'll see how that one runs. And now we've stepped it up into this wonderful monster throwing straight up, but of course it's coalescing with, it's joining with another script that I have behind it. So we'll get to that other script in a minute, but let's just, for simplicity's sake, leave this as what it was. And you can see it doesn't matter if that pops down to the next line, it just doesn't look very good if you do that. Okay. Then I have an if statement, and I'm using modulus. If I, the iteration I, the number divided by num1, which is actually a parameter I can bring in, is equal to 4, which means it has equal to 0, which means it has no remainder, and j, similarly with num2, has no remainder, then you would be able to select those, send those points to point 1, and then you output them to A. And you could output them to points 1 output, whatever you want to call it. You just have to make sure it matches up the name in the output over here. And you'll find that out as you play around and watch some tutorials. This one isn't really a step-by-step one. It's just to show you some ideas to get you building some geometries. And then else if elif statement is used for an or conditional, if one is true or another one is true. And then else is happening. Everything else is defaults to points 3. So you get these sets, and these sets. And you can do whatever you want with them. I'm going to close that one out. We're going to go into something new here that I haven't done. And we're going to go into the random library and take off all the other stuff. Nothing's going to be generated here, just a simple system of using random. And this is where we're starting to import things like import Rhino, import math. And these are all wonderful things that if you just type 0, you can see all the functions you can gain in those libraries. You get more and more accustomed to doing that. I like to import maths quite a bit, and I haven't used it in here, but we could. I'll just show an example of it. If I wanted to throw one in here, I would type in math dot and probably square root. And that should allow me with a little bit of parentheses around here, keeping in mind I have to close the bottom one. Let's just see what that does to the number system when I run it. There, changed our numbers up because I've actually used math. But basically I have a random number that's being generated, random, which is fine, and I'm getting any, and that will default and give me anything I believe between 0 and 1. And if I do it again, I should get another number, another number, another number, another number. And then random integer is going to give me a random integer between 0 and 10. So that's nice. Actually, it would have, except I put in the square root of 100. So it'll go, yeah, it would have done up to 100, but I took the square root of that. And then a random uniform is interesting because it'll give you as many decimals as you have in there. And it's just pulling a random between 0 and 100. You're getting a pretty cool number system. Actually, I saw a 0 point. And then I'm outputting those to ABC, and you just have to assign those to them. So let's try and apply that random and make that a little more interesting. So a random library here, fairly simple. Here are the points, nice and simple to start with. I've set my seed to 10, which means if I jostle that, I'll get a different pattern. And I set my count to 100, use the number n. So what have I done here? Run Rhino, import random, made an empty list, and for I, as I iterate through n, which would be 71, I will make a point, rhino.geometry.point3d, not add point, which would be Rhino Script syntax. I will take my random library, I will find uniform, and I will set it between 0 and 10, and there's no step in there. And I can also set my random uniform between 0 and 10 for the y, and I'm ending up with these points as they scoot around in that direction. And I left z at 0. So I'm getting a random grid of points, which can be great for selecting a few of them and starting to iterate lines through them. And I'll try and do that. So very simple tools. Here's another random library applied. Having a little bit of fun with this and coloring it. And this is where we got into the big monster. And of course, the only way you're going to see this one is if I turn it off and click over here. What I used was exactly what they used in the book. And I'm not pushing any plugins here, but you can see that I've used a custom preview, a color RGB, and the Python script. And what that does in these points, it has a step value that I could set the steps high, and you'll see what it does. But if I start to bring it lower, I start to get a lot more points and a lot slower script, but they start to get a nice range of what's happening there. So let's leave it high at 20, and let's take a look into the script. So what I've done here is taken from their script. Really the only change is add point being shifted over to the 3D point, and import Rhino. Open yourself up with a list as points. RGB are separate lists, so you have to create them off the bat. And then for I in range, I use the color system of 256 all the way up to the step, and I made the step parametric like I showed you earlier, that I can actually slide that around and run that through I, J, and K. I'm going to make my point equal to the Rhino geometry at point 3D IJK. I will append that list, points being appended to P, T, point, and then R will be appended for I, J, G will be appended for J, and B will be appended for K. And the outputs are set again, ABC to RBG. And you could actually just type in RBG here, but I get in the habit of outputting this so it's consistent. Very simple script, but you get a nice little colorful node, and of course you're starting to do things in Grasshopper on the other side. What you've ended up doing here is selecting certain points, all different values where they are. Okay, so that's fairly simple. And now we're going to import the maths, which I think is a great tool. And we're going to go down here and get rid of that other one, jump in here and say, how is this little curly Q happening? And why is that so exciting? And why does it start? Well, there's no change happening here, but let me open up and I'll show you what's happening with that parameter. N, and I'll show you exactly why that's not working. I have imported Rhino Script syntax because the F range is working well in there. And the F range allows you to have a float. And I think you can have it in as just a F range as well, and it'll work as well. The fx and the F range are two functions that are built into the Rhino Script syntax. And then down here, I've still used Rhino Geometry. I've asked online and tried to find out the alternative for having to use Rhino Script syntax. One thing that people do is when they import it, they usually import it as RS, and then they can just write a nice small script RS here, but it's too hard for me to tell the difference if I import rhino.geometry as RG, is I get in the habit of forgetting which ones are and which ones are G, and then I start using different functions like add point and 3D point, and that can be hard. I did import the math so I could pull in some curves, and I thought this was fairly interesting. Starting at, I didn't want to start at 0. There was a trouble with starting at 0. I guess I could have, but I just left it at 0.1 to show it was a decimal. I could put 0.0, and we've got this nice little iteration kind of flowing through. And I had my N in here for a time, but why did I take it out? Let me just think for 1 second. I must have been doing something and then I removed it. Interestingly enough, I probably was doing a little multiplication within here to play with it, or I might have played with a series of steps. Not sure why I made that parametric. Let me just take a look for a second. Type hint was set to float. And maybe I was just trying to play around with the float and the integer at the time, even though this one's not even set to rational number. So it wouldn't have mattered anyhow that it was set to float. I'm not even using n in the script. So just playing off that for a second, math library, why would I have done that? Maybe I was multiplying in time. Can't remember what I was doing. I had multiple ones flying around. But it is a list of points. It's been generated, X, Y, Z. Let me... Interesting. Let me just play around a little bit with some of these numbers. Let's take that up to 100 and see where we go. I'm sure it's going to blow up into a very nice high top position. Now you start to get an interesting pattern as it happens. That's exactly where I was playing. I had N in here. Just took me a second to remember what I had, and that's where I was playing around with N, just the height of that whipping around and being something. Just to make it a little parametric instead of be dependent on that 100. But then I got stuck playing with the F range fight function, trying to get things into floats and trying to get them into geometries. Anyway, I write these over the course of the day, and then I kind of come back and talk a little bit about them. So let's hit OK on that one. Let's go down to a line and curve. This one's pretty simple. You've got 2 points, and I brought them in. There they are. And I've drawn a line between them. Now, that can get very complex all of a sudden, but you want to learn from the start, just like the way you're making points, you're going to want to go in and learn how to make a line. And the way you make a line in Rhino Geometry is a little different from add line in Rhino Script syntax. It's actually simpler. Rhino.geometry.line, and it'll ask for 2 points. And one thing you can do there is that's once again a nice thing to do. Line 2 equal to Rhino.geometry.line. And then when you put that in, it'll tell you some wonderful ways to actually fabricate that line. And you can do it through a whole series of, you'll need a from point 3D to point 3D. You could do from point to a span of vector. If you can make vectors, then you can start to bring those in. 3D point, direction vector, and the length being a float. And you can also do them from a float, float, a float, and a float, a float, a float. So many little ways to generate that, and as you get more and more accustomed to looking into things like that and seeing those colons and what's decided, you'll become better and better at scripting this. And then the line out is just set to line. So fairly simple. Just run your script, make sure it's working. There it is. And once you realize the power of this and putting it through loops and baking the geometries while you run it, it can get very interesting in Rhino as you go in here and start playing with these points. If that's the point being generated and then I'm able to slide these around and see what's going on, I just have to take off all my information. But what's nice is you can set this into Rhino view window and start at rhino.rhino.doc.active.doc. You can start to really generate these geometries, and they'll bake as they go, and you can actually draw and model in real time by sliding around your sliders using a Python node. And I'll show you examples of that later. But that's one of the things I'm very excited about with experimenting with. Okay, so we'll go down to line and curve, which is fairly interesting. What I did here, just to keep things straight, is I generated a box, and I decided to put in 8 points. I could put in less or more, and I basically want to drive a curve from those points that are in there. Ooh, hard to chase it because we've got so much geometry here, but you can see as you change your points, you're going to change your point count, you're going to change it. And you can also have a degree function in here afterwards in my Python, which allows me to go from polyline to different degree NURBS curves, which are pretty exciting. That's really when it's about all the way up to degree 5. So degree 1, 2, 3, 4, 5. And you have an effect on that curve. And that beats going in and having to make the Rhino script, add polyline, add curve, and add interp curve. You can just do it all in one function. And it's actually a NURBS curve function. So this is one you really want to get down. It's one I use quite a bit. And it's fairly simple. Import Rhino. And curve A will be rhino.geometry.NURBS curve create, and then you must set up if it's periodic or not. So if I change this one to true, you're going to see what happens. Oop. And of course, you have to spell capital T in Python or else things get ugly. I thought I left. That was interesting. Back, Shift T, and let's test it. It should close. There we go. So we have our curves closed. We can even have our polylines closed. And we can have our different degree curves closed. You set the degree here, and degree, of course, is made parametric because I brought it in as an input, and points are what's coming in from my populate. So as I take this up, I can change that all. Really have some fun with a very interesting curve, very interesting script. But get in the habit of getting into the geometry namespace and experiencing the power of creating NURBS curve from random points. Very good tool. Next one is a curve by random points. And we're going to jump in here, and what do I need? Oh, looks like the kids are home. I'm going to interrupt the video, but that's fine. What I have here is curve by random points. I jumped in here, and let me just take a second if I have to. Dog's going to be jumping. I started a list, and I think I'm going to have to go out. There we go. Yeah, very interesting curve created by these points. So these are the control points that are kind of controlling this curve. And what I've done is made a list of points. There they are. Left them empty and used the random function uniform to go from 0 to 100 in the XYZ. And then I created 3D points in that list and appended that list. And the curves is the NURBS curve create. And once again, I used false. It's an open curve. Degree 3 points. Excuse me. Provided from the loop. So very simple. Nice curve, but when you get into it, you could once again change the X value to M. You could change the Y value to N, and not a good, better go to P. And let's go in here and change this to N and make that a float. And let's make this one M and make that a float. Of course, everything changes every time you do it. And let's make this one P and make that a float. And then let's get in here and do a 12.0 and start sliding this around. And this will be the extent of how big this thing grows. And I should be able to run it. It should be a fairly interesting script. Oh, I need an integer. I can't be doing that. I apologize. I have to think a little better than that. Okay, let's get in here and do type hint integer. Type hint integer. Type hint integer. Now I should be able to run it with any luck. Where did they all go? What is going wrong? Everything's there. Random NMOP. Maybe because they're all the same number, that's not too good. Well, that should be fine. I've got it in there. Random. 10. Huh. Strange. What? Oh, I just didn't select my points. I usually am foolish in some way. But now you can control your X, Y, Z by this and get some really nice points and curves because of that. And I could grab another one here and slide that into my Z. And it's all right to see somebody kind of fudging around and having a little bit of fun with this because it can be very difficult, but you can pull that down in the Z direction, you can pull this back down in the Y, and you can pull this back down in the X and get this fairly small curve. And the points are still being defined by 10, but if you want to, you can go in here and type in 30 points. You're going to get a much more complex curve as it iterates through all of those wonderful points and tries to follow. Wonderful use of lines and curves in generating using the NURBS curve function and the random function. We're getting to the end of it. This is the end of it right here, dealing with points. And what I want to show you is that I had a lot of trouble going in here to what was being offered to me. Taking a curve, which is this curve, which I have, it's a planar curve, and I've set it to a plane that if we want to look at it would be there. This might be best if I just take all my other scripts and turn them disabled. And now we can see what's going on. I basically have a plane, points, and a curve. And I'm asking that curve, first of all, using Rhino Script syntax. And this is the script I found. And I had a little challenge with this, and it was quite frustrating. And you'll see I've got a bunch of data here coming out. I made a list. For I and 12, I generated points, uniform between 0 and 10 in the X and Y directions, 0 on the Z. And then I started thinking of a Boolean. Now, the function in Rhino Script syntax of point in planar closed curve gives you a 1 or 0. And if that's the case, you can just take those 1s and 0s, which are here, and you can append it to Boolean. And then if Boolean is true, go through I and append list points in, which means these points are in the loop. I'll just have to make sure I grab them. Let me just grab here and make these visible. They're on the other side. There we go. So you end up getting the points in and the points out. Don't let it confuse you because you're actually seeing these points. So let me take these off. So you're actually taking a look at the points that are in this curve and the points that are out of this curve. And every time you generate it and move it around and run it, you're going to get points in and out again. So the points in, the points that are out. And that was a nice tool that was offered. And I just spent way too much time today, probably an hour, sending forum notes, trying to find out how I could do this in Rhino geometry. And finally, I just scrapped it, got a little bit of advice, and rewrote that script over in what I really wanted to do. And the trick with this is, you'll notice the main difference is these are Booleans, 1s and 0s, coming out of the Boolean. And these are outsides and insides, which are not 1s and 0s. They are not true and false. So what I've done here is I've gone in and I rewrote the script and imported Rhino, imported random, did not import Rhino Script syntax, used the same script at the beginning to generate points, which are these points here. Let me go over here and take these ones off and turn these ones on. And this will be the Rhino common namespace that's at work. And you can see here, as I grab the ones inside, those are the ones outside, those are the ones inside. And actually, I haven't typed out and in, they're reverse. I should have checked that. But it's just the number that I have set to it. Yeah, I should swap those two names. But made a blank list for Boolean, blank list for points in, blank list for points out. And then, even though this took me forever to figure it out, I did find the namespace rhino.geometry.curve contains, which asked for a little bit different. It didn't just ask for a curve and points. It asked for curve, points, plane, and a tolerance. And in doing so, then you can append the points in or out with that list. And then you have to change, which was simple enough as if Boolean I in the list indices is equal to true or false, you have to change that to rhino.geometry.pointContainment.outside and inside. And that took me forever to find. But the more you spend time looking through the namespaces on Rhino Common, the more you'll see things you never knew were there, and you realize there's tons of ways to create scripts and make things, but you're not dependent on the Rhino Script syntax functions. So we're going on about 20 minutes, 30 minutes maybe, and I'd like to end with this because the script works very well. And as you test it, you end up with this, but you also can go in and have fun with extracting your parameter. You can take this curve. Actually, what I'll do is I'll bake that curve. I'll just make it visible again. And what I can do is move that. And that's a interesting way to change that planar curve and see what's inside and out. So I thought that was interesting. So I've selected the out ones and the in ones. As I change that, play around with it, scale it. As long as it's a closed curve, it'll work. Have to play a little bit, have to be a little particular about that. And your points are jumping inside and outside and telling you what's in or out. And that's going to be a tool in script I use quite a bit. So nice little system of going into a script and finding out, are the points contained in a closed curve, and writing the script for that. What is in, what is out, and what are all the points being generated. Of course, if you go back into your initial one and you change that to 120 and run it again, you're going to get a lot of points, and then you're going to get the points that are in, the points that are out. And this is actually going to be fun for finding, placing people within structures and building parameters. Very exciting to start thinking the application of these things. I think that's it. So I will continue to struggle with trying to take the scripts I'm finding within this book, bringing it out into Python, but changing it drastically to try and have an understanding. And this is frustrating me, so I'm just going to put that one over there and that one over there. And that's not going to change anything. That just changed my points. Funny that I thought that would do something. I'm actually going to have to call. I'm going to have to go into my script. And I'm going to have to ensure that when I asked outside, inside, this should have said inside. It's not that easy. And outside. And that should allow me to do it. And if I run that now, it should be better when I click the outside ones and the inside ones. Oh, no, same thing. What did I do wrong? Yeah, there's inside and there's outside. Now it's working. And as I play with that little geometry and move it around, if you take it off the planar, it still doesn't matter because it does a nice job projecting down, so you can put your curve wherever you want. I did not mean to extend it like that. I meant to move it like that. You can see how that functions well. And probably the best way to appreciate that script would be to go in the top view. Have some fun this way. Move that around. Very cool little script for getting control of what you're doing. Thank you very much for watching. We're going to move on to something more complex, and I will take my time in building a whole entire script for it. I hope this comes in handy. The scripts themselves are here on one GH file dealing with points, and they're basically a look at Rhino geometry namespaces, or actually Rhino common namespaces, and we're doing the Ghpython nodes at Wickerson Studios, starting with points, and we'll go hard into vectors next, and we'll have some customized scripts that go with that. So please stay with it and keep watching, and about half an hour to watch these videos. I'll try and make them a little smoother.